Evaluate the indefinite integral. So here we have the integral of parentheses 3t plus 2 to the power of 2.4 times dt. So the first thing we're going to do is use substitution, and we're going to let u equal the quantity inside the parentheses. So we're going to let u equal 3t plus 2. Okay, now we're going to take the derivative of both sides. Taking the derivative of u is going to give us du, and the derivative of 3t is going to be 3 dt, and the derivative of 2 is 0. Okay, so if we come back up to the original question, you can see that dt is the only thing that we need to substitute, so we need to bring this 3 to the other side of the equation. So in order to do that, we're going to divide both sides by 3. And so we end up with 1/3 du, which is equal to dt. So now let's go ahead and rewrite the original question. So we have the integral of 3t plus 2 to the power of 2.4 dt. So now we're going to use the original substitution, which is 3t plus 2 is equal to u. So therefore, this is going to be u to the power of 2.4 times dt, and dt down here is equal to 1/3 du. So that's times 1/3 du. So now we're going to factor out the 1/3, and then we have the integral u to the power of 2.4 du. And now we're going to take the antiderivative of u to the power of 2.4. So that's going to equal u to the power of 2.4 plus 1 over 2.4 plus 1 plus the constant c. Okay, so now what we're going to do is we have 1/3 times u to the power of 2.4 plus 1, which is 3.4. And then down at the bottom, 2.4 plus 1 is 3.4 plus c. Okay, now we're going to rewrite the fraction. So this is going to be 1 over, well, 3 times 3.4 is going to give us 10.2 times u to the power of 3.4 plus c. And now we're going to go ahead and put in the substitution for u, which is 3t plus 2. So this is going to equal 1 over 10.2 times 3t plus 2 to the power of 3.4 plus c. And therefore there is our result.